HNC, modelling a vibration with this function. So we have a sinusoidal function that looks like that. So that could be some sort of rotating machinery causing a vibration over a period of time. This is how displacement will behave. We're going to a maximum here, back to a minimum again. And it's cyclical, okay? So this blue function is modelled by this. So we're interested in knowing at what time is the displacement minus 2 mil. So I basically want to know when is this point here. I'm going to do it algebraically and then show it graphically. So this occurs here, it also occurs here, and for a third time. You know, for everyone after that. Assuming all conditions remain the same. Okay. So when it's at minus 2 mil, then the displacement y is minus 2. So that's enabled me to write this line here. So to find this time, all I need to do now is solve this equation. So when solving equations, all I'm really doing is remove that, stripping everything away and leaving t on its own. So that's why I've written these steps here. So first of all, I'm going to divide by both sides of the equation by 5, or do to one side, or do to the other side. I then do inverse sine, or do to one side, or do to the other side. I then add this to pi over 7, do to one side, or to the other side, and finally divide by 100 pi. So I'm going to do 2 steps at once, because that's as much space I've got on the board. So dividing both sides by 5 and inverse sine gives me 100 pi t minus 2 pi over 7 is minus 0.41152. Okay, so we've just done those 2 bits. So your last 2 bits, add 2 pi over 7 to both sides and then divide by 100 pi, and that'll give me t. There's a decimal, that comes to 0.00154 seconds. Now if you press your ENG button on a calculator, it looks a bit like that. The correct prefix is 1.54 milliseconds. So hopefully this is when this vibration, the time at which is minus 2 mil displacement. So we're going to check that using a website called Desmos, and I should get commission for this. So here it is. Now you can't see that clearly, that's the y equals 5 sine bracket 100 pi t minus 2 pi 7, okay? So the time at which so it's there, and that is confirming what we've got, okay? So that's it.